Hi friends, how are you? Welcome back to my channel. Today we are going to discuss the most important topic, that is the power source of arc welding. From where you can get the power for arc welding, that is AC or DC welding you can say. So we'll discuss in details, and what electrode used for arc welding we will also discuss. So let's start. Prior to start this discussion, those are new and still not subscribe my channel, please subscribe to get the regular update and you will not miss any videos in the future. And press the bell notification to get all the updates every time. So let's start. So discussion will be the first one, the power of arc welding AC or DC, which one is preferable. Means DC welding where we can use, and the AC welding where we can use. And what is the advantages and disadvantages, all will discuss. Types of electrode used for arc welding, which types of electrode we can use for arc welding. Function of coating, if there is a coating of the electrode, so what is the function. Disadvantages, if there is a coating in the electrode, what will be the disadvantages. Classification of arc welding, what is the classification of arc welding based on the electrode used, we can see. Effect on shielding gas in welding, inert gas or reactive gas. So what is the effect if there is a shielding gas is used in welding, or inert gas or reactive gas. So let's see the first one. You can see here is a one graph. What is the graph meaning? You see here the magnitude and this is the time. So alternating current, how it is flows is like that. Okay, and direct current you see here is the magnitude and the time. You can see the one side is direction is constant. So what is the main difference in AC and DC? You can see the AC current reverses direction while flowing in circuit, whereas DC current not changes direction. So in magnitude you see here the its glow goes like this way, flows, and again up to 180 degree, then again it's changed to flows from here to here is direction. So that is called the flows reverse direction, flowing in the circuit in the reverse direction, that is called AC. And direction, if it is go in the single direction, that is called the DC. So you understand AC and DC, this is the main difference. And AC current, if you hear the magnitude is there, it can see the frequency. But DC current, if there is no direction, it is a single direction, it is a constant, so there is not any frequency. Now the question is there, what is AC and DC? We'll go the details. Now before we start the AC and DC welding, we need some information to know. AC and DC welding are forms for arc welding. It is a forms of arc welding that use different current produces in electric arc. So there is current produces an electric arc in AC and DC welding. So what is an electric arc? We should know. Electric arc is produces in between electrode and metal. So you understand, here is your metal, okay, and this is your electrode. So electric arc produced in this condition. So that then in this condition, what is the produces? Electric arc. So electric arc is produces in the electrode and the metal in the between. Now what is the use of electric arc? You see the here is electric arc produced. What is the use of electric arc? Electric arc provided heats. It generates heats here to fuse the metal. So fuse the metal, also the electrode, both can fuse here, and it forms a welding now. So what is the use of electric arc? You understand. Now it's mentioned heat, provides heat. From where you get the heat? If there is no power supply is there, then definitely you cannot get the heat. So that is power supply is AC and DC. You understand the full from here to here. This is the general concept you should know. Now AC and DC welding will go the details. Next we will go here how to choose the polarity. You have to choose the polarity. How? This is the very important. It decides which polarity of the electrical current runs through the electrode. Which current it runs in the electrode, that is the polarity. This is simple. Now polarity have, we know the two types, that is one is positive polarity and the negative polarity. So we'll discuss one by one the positive polarity and negative polarity for each DC welding and AC welding there is present. So each DC and AC welding, we can see the DC positive, DC negative also. So the AC positive and AC negative also. The polarity have two polarity now, positive and negative. Now DC polarity is always constant. AC polarity flows in one direction for half of the time and half of the time other. So you know the DC polarity is always constant. This is the one direction only, and the AC polarity flows in one direction of the half of the time and the half of the time other. So now we'll go the definition. What is DC welding? So DC welding is, DC polarity is different. So DC welding is, direct current is an electric current that has constant polarity. So DC welding has the constant polarity. So you understand the DC welding, the constant polarity. It's flow in a single direction. The current can be positive, may be negative. So current can be positive or negative. Here is very important. The magnetic field and the current arc is constant. That's why you can see the stable arc. Stable arc you can see in here in DC weldings. That's why you can get the good quality in welding. Now we'll go the DC welding, the advantages. You see advantages is welding output is very good, smoother than AC. Because the AC there is a frequency, a more stable arc we can get, spatter will not be there. DC positive offer faster penetration rate, means faster deposition rate, and DC positive also good penetration. This is the advantages of the DC welding. What is the disadvantages? If you go arc blow, we cannot fix. This is a big problem in DC welding. The arc blow, it can be there. Equipment is more expensive. So equipment is DC welding because of there is connection of transformer inside to switch. That's why it's very expensive. And what is the application? Where are the application of DC welding? DC welding you can get only in thinner metal. Thinner metal basically it is used in DC welding, and for stick welding we can see, and the vertical and overhead both position could be welded. So this position, vertical and overhead both position could be welded in this DC welding. So now we understand the DC welding. Now we'll go the AC. What is AC welding? Already discussed. AC welding, that the current fluctuate, means that is reverse its direction many times. Currents reverse its direction in its many times. And advantages of AC welding, you can AC current, what will happen between positive and negative polarity, steadier arc we can get here. Stable arc, steadier arc is the other same. So steadier arc we can get here. Fixed problem with arc blow. Arc blow you cannot see here in this AC welding. Effective for aluminium welding. That is why AC, that's why it is effective for aluminium welding. It removes oxides. That's why it is very good for AC welding. AC machine cheaper than DC. So this is the advantages. And disadvantages, what is there? Spatter is more. You can get so many spatter. Welding quality is not smooth as DC, and more difficult to handle weld than DC. That's why aluminium welding is very difficult. More quality welder is there. What is the application? What are the application is there? It helps to remove oxide from the metal surface. This is the very important. It helps to remove the oxide from the metal surface, this AC welding. That's why it is used for aluminium welding. AC welding widely used in CSWIP welding, mainly in seam welding. You can see it is used for down or fast filling. Down hand you can see here, and the fast filling is there. One of the main uses of AC welding is the material that is magnetized. This makes it useful repairing machinery. So AC welding, it is very good for repairing the machinery. So you understand the AC welding advantages, disadvantages, and the application. So you require AC and DC. It depends upon the company requirement, depends upon the specification, depends upon the WPS, what is mentioned is there. So it is clear where you have to use the AC, where you have to use the DC. So now we will discuss the electrodes for arc welding. What electrode used for arc welding? Electrode we can divide it in two parts. One is the consumable, another is the non-consumable. So we'll go the consumable electrode first. In consumable electrode, what is the function of consumable electrode? For arc welding, to act as an anode or cathode, it will be act as an anode or cathode to produce the arc. And then arc produces the heat from where it can get the heat from the power supply. Also, the electrode melt itself and get transformed in the whirlpool to form a molten metal and forms the bond solidification. Means electrode melt itself in consumable. In consumable part, there is electrode is the melt itself and get transferred to the whirlpool, and after the whirlpool it bonds the solidification, and electrode act as a filler. Now non-consumable, you can see, to act as the anode cathode, but just to produce the arc. So only in non-consumable, what is the function of electrode? The act as the anode cathode and only produces the arc, but it will not melt. It does not get melted. Means non-consumable electrode, the non-consumable part, it will not get melted. Only we need a separate filler metal has to introduce separately. Means separate filler metal it needs to get the melted the filler metal and the whirlpool, and that act as a filler. So this is the consumable and non-consumable part. Now you can see here the two parts in welding. One is non-consumable electrode, another is the consumable electrode. So in case of non-consumable electrode, what we can see, the high melting point, so the electrode does not get melted. So high melting point is there in non-consumable electrode for the tungsten electrode, that is very high melting point. So that's why we are using the tungsten using, because it will not be melted. So high melting point, so that electrode does not get melted. Normally used electrode are carbon, called carbon arc welding, tungsten for called tungsten inert gas welding or TIG welding. So we can use for carbon or we can use for tungsten. If it is tungsten, then it will be tungsten inert gas welding. If it is carbon, then it will be the carbon arc welding. So you understand the non-consumable electrode. Now we'll go the consumable electrode. You see the melting point of electrode. If you see the electrode and the base metal, the melting point is same. So that it is normally used for electrode at MS, SS, cast iron welding process, normally referred to the metal arc welding. So we can called here this welding the metal arc welding, and you can see here the tungsten inert gas welding, because this one it is not consumed. The additional filler wire is required to mold the weld pool. So you understand this non-consumable electrode and consumable electrode. Now we'll go. Now in consumable electrode there is two parts. One is bare electrode, another is the coated electrode. In bare electrode you can see there is no coating. You can say ER70S to 1.6 mm, that is for MIG welding used. You can see the solid wire, that is no coating, that is called the bare electrode. In the coated electrode you can see electrode, you can say E60137018, all is the coated electrode. You see the coating is here, and this is the bare electrode. This is the difference of bare electrode and the coating electrode. Now function of coating. What is the function of coating? The most important part. There is a function, there is a coating in that electrode. So generate inert gas like CO2, which will shield the weld metal pool and prevents the molten metal from the reacting with atmosphere, oxygen, hydrogen, nitrogen. Hence weld will be strong. So when the arc is generated, in that time that produces the CO2, which will shield the weld metal. So means it protects the weld metal pool. It prevents, if it is not protect, what will happen? It can be contaminated with oxygen, hydrogen, nitrogen, all also contaminated with the some portion with air. So maybe quality will cannot be strong. So that's needs for weld to shield. That is the CO2 gas. It shield the weld metal to prevent the molten metal. So contain flux which react with atmospheric oxygen from slag, which will be less denser than molten metal and hence will settle on top of the molten metal. The slag will protect the molten metal from atmospheric oxygen, hydrogen, nitrogen. The slag is later removed by chipping. So there is produced slag. That slag is very important to protect the molten metal, also atmospheric oxygen, hydrogen and nitrogen. And you can later slag can be removed. The metal pool is covered by slag, helps in gradual cooling of metal as metal is not direct contact with air. So this is the very important. The metal pool is covered by slag and it is normally cooling in the air. So definitely there is the good quality we can get here. Coatings are means to introduce alloying element to make the wool strong. Means if there is a coating, definitely there is alloying element to make the wool strong. Help the stabilize the arc. We can get the stabilize the arc. So the weld pool is thus shielded by shielding gas from the generated from the coating during welding and also by the formation by slag. So the weld pool is shielded by shielding gas from the generated from where the coating during welding, also by the formation of the slag. Thus the welding process is popularly known as shielded metal arc welding. That's why it's called the shielded metal arc welding. Means it is shielded by the CO2 gas. So it is the function of coating. This is the most important you should know. If you any interview, they will ask this type of question. Now disadvantages, there is a coating is there. What will be the disadvantages? You see, disadvantage is very easy. Coating will absorb moisture. You see there is coating is here. So this will absorb what? Moisture will absorb. And H2O will split between H2 and O2. This O2, what will happen? Will go to the weld pool. Hence oxidation of the weld joint will take place, leading the less strength. If oxidation is there, definitely it may be crack in that portion. Preventive method is preheating of electrode in oven to remove moisture. So always we need to preheating of the electrode prior to start the welding to remove the moisture. You see here the oven. This is the mother oven, you can say, and this is the portable oven. So mother oven, it is 250 to 370 degree you have to reach there first. Okay. Then in the portable oven you have to carry 100 degree centigrade continuously. That is called the holding oven. The ER70S2, this is the bare electrode. So if you see the when coating electrode are used, coated electrode, the coating will form a slag. There is a slag they are produced and protect the oil pool from getting contaminated. In case of bare electrode, what will happen? There is not coating anything. So what will happen in that case? So we'll discuss. You can see there the bare electrode for arc welding. The bare electrode for arc welding, what is the requirement? You see molten old metal is here. Molten, this is called the molten oil pool. This is the molten oil pool. This is the wire pit consumable electrode. This is the arc is generating here, and this is the shielding gas. So this is the requirement of the MIG welding. You can say continuous wire is there. The feeding from here it is continuously going like this. This is the gas cylinder. This is the power supply. This is the wire feed unit. This is the MIG gun. This is the arc. This is the arc clamp, and this is the workpiece. This is the requirement in a basic requirements of the MIG welding. Now, if you see the bare electrode, what will happen? A shielding gas is there. You see, this is the creating the shield. Usually, an inert gas like argon is supplied, which will protect the oil pool. So, here who will protect the oil pool? This is the argon is protect the oil pool. In the electrode, this is the coating is protect the oil pool. That is, here it is the MIG welding. You can say called the bare electrode. If it is non-consumable electrode for arc welding, so if it is non-consumable electrode for arc welding, electrode does not get melted. It will not melted. It only forms the arc. In non-consumable electrode, what will happen? Electrode it's not melted. Only get the arc. Electrode will have high melting point. That is the tungsten. When tungsten is used as non-consumable electrode, when welding is called the tungsten inert gas welding. Definitely you need a gas for that one to melt it. When coated electrode are used for coating will form a slag and protect the oil pool from getting contaminated. But what protect the oil pool when non-consumable electrode are used? Okay. In coated electrode you can see there is a slag and protect the oil pool from getting contaminated, the coating. But non-consumable electrode, what to protect? Now we can see here when non-consumable electrodes for arc welding. So you are using the non-consumable electrode for arc welding. So what is the things we need to see here? You see electrode holder. You have to see first nomenclature. this is the workpiece. Okay, this is the arc is generating from here. You see, this is the gap. So gap, in the gap the arc is generated. The tungsten electrode, this is the tungsten electrode. This is the tungsten electrode. Okay, and the shielding gas, this is the shielding gas. The electrode holder, this is the electrode holder. Okay, and this is the welding power source. This is the gas supply. So you understand the nomenclature of this non-consumable electrode for arc welding. So the tungsten electrode, this is one, and the electrode holder, this one, this one. So this is the tungsten, this is the electrode, mean tungsten electrode. Okay, and the additional filler wire always you have to put here. Okay, to fill this groove or fill this fillet. So you understand the non-consumable electrode for arc welding, what is this uses. So when non-consumable electrodes are used, a shielding gas, usually an inert gas like argon, is supplied, which will protect the weld pool. So if you see the non-consumable electrode, a shielding gas always used because we need to protect the weld pool. So how shielding gas is required, as the inert gas like argon is supplied, which will protect the weld pool. But in coated electrode, you see coating itself, it's a protect the weld pool. So that is called the SMW welding. That now here is the TIG welding, tungsten inert gas welding. So here is shielding gas, that is coated electrode. So this is the things we need to know regarding the how to protect the weld pool. Now we'll go the classification of arc welding based on the electrode. This is the important arc welding classification on electrode use. One is consumable electrode and the non-consumable electrode. If you go consumable electrode, the metal arc welding, silted metal arc welding, electroslag welding, metal inert gas welding, all these are consumable. You can see submerged arc welding, all filler metal or call the electrode is the consumable. But in non-consumable, you got tungsten inert gas. This is the TIG welding, carbon arc, atomic hydrogen welding, plasma arc welding. These are the all are non-consumable electrode, and the separate filler wire always used to get the welding. Effect on shielding gas in welding. What is the effect of shielding gas in welding? The primary purpose of shielding gas to prevent exposure of the molten weld pool into oxygen, nitrogen and hydrogen contaminated in the atmosphere. If there is a not shielding gas is there, so the nitrogen, hydrogen and oxygen in the atmosphere, it contaminates the weld pool. So purpose of the shielding gas to prevent exposure of the weld pool to oxygen, nitrogen and hydrogen content in the air atmosphere. The reaction of these elements of the weld pool can create a variety of problem, including porosity, excessive pattern. So in that case, if the shielding gas it's not correctly used in that welding, then definitely it can be seen here, including porosity or excessive spatter. The typical welding gases are carbon dioxide, argon or argon blend with carbon dioxide, argon blends in argon with CO2, argon with helium, argon with nitrogen, argon with hydrogen, hydrogen with oxygen. So this is the called argon blends. So you can use the carbon dioxide, argon or argon blends, the typical welding gases. So the gases can be separated into two categories. One is the inert gas, one is the reactive gas. So what is the inert gases? Inert gases, you can see here the bead contour and penetration patterns of various shielding gas. If it is argon, you see the bead contour how it is look like. Argon plus helium, argon or helium, that is this is the looks. Helium you can see, this is the bead appearance, and CO2 you can see the bead appearance. So every gas have their own bead appearance. You see argon and helium are inert gas. This means that neither gas will chemically react with molten metal. So inert gas, it's not means it reacts with the molten weld pool. Argon is the most widely used inert gas since it is readily available and inexpensive compared to helium. So we are using the inert gas. Why? Because it is not expensive too much as helium. It produces a finger-like penetration profile. Helium has a very high thermal conductivity. So helium is a very high thermal conductivity compared to argon, and it is used for hotter arc. Helium provides broad but shallow penetration. So penetration is shallow, but it is the broad bead. So reactive gas, we can see the reactive gas. Reactive effect on oxygen versus CO2 addition in the argon seal. Actually, we are using for this one for the fillet joint. You can see argon oxygen, argon CO2 and CO2. What is the bead appearance, how it is look like. Carbon dioxide, oxygen, nitrogen and hydrogen are reactive shielding gases. So reactive shielding gases, carbon dioxide, oxygen, nitrogen and hydrogen. These gases combines chemically. So it is combines chemically with the weld pool, affecting mechanical and chemical properties of the weld metal. So this gas always combine argon oxygen, argon CO2 or also only CO2. Carbon dioxide is the only one that can be used alone. So carbon dioxide you can use alone as a shielding gas, but in argon it cannot do alone. It should be need CO2. Argon also need oxygen. All can be combined with argon to get binary shielding gas blind. So you understand the reactive gases. Thanks for watching the video. If you still have any questions, please just give a comment in the YouTube comment box, then I will reply to you. Hope you understand the electrode required for arc welding and also the power required for the arc welding, that is DC or AC. So those people still not subscribe my channel, please subscribe to get the regular updates. Thanks a lot.